as we have done transformations of both linear and exponential functions, and now we need to look at it with a quadratic. So that's what we are going to be looking at today. Remember, a quadratic is a squared function, meaning it has a highest exponent of 2. It creates a parabola. So that's what we are looking at. So when we compare two functions that may or may not be graphed, we always compare it to y equals x squared. What do we call this basic form? Who remembers the name of something that's the most bacon? Bacon.
Bacon.
Okay.
Like bacon.
It is the parent. So we have parents for every single one of the functions we talk about. The parent of a line is y equals x because the slope is 1 and you start at the origin. So we can make it steeper or less steep from the origin, or we can move it up and down on the y. So we can transform it from that point. We can also do a transformation. We can also do a transformation on an exponential, which is y equals b to the x power. Remember, b has to be the same. So if we have like y equals 2 to the x, it creates our exponential curve, and our asymptote is at 0. We can shift it up so our asymptote is at, a higher number or lower number. We can also stretch it and make it go up quicker, or compress it and make it go down or go up slower. So these are our things that we can do in all the cases. So the parent is the most basic. We will discuss translating the graph, which is f of x is plus or minus k, which translates the graph of f of x vertically. Remember what we talked about yesterday with k. If k is positive, we go up, and if k is negative, we go down. So it takes that original y equals x squared graph and shifts it up or down. Now, remember, if it's inside the parentheses, like inside the square piece of the parenthesis, right, we have plus or minus h. It shifts the graph of f of x horizontally, but this is a little bit opposite than what we're used to, because if it's positive h, it actually goes left, and if it's negative h, it goes right. So that might be a little confusing to you guys, but we're reinforcing that idea today.
Like the left.
All right. The last thing we are going to talk about is a reflection over the y-axis, which is the vertical axis. So a reflection over the y-axis is this axis here. So if it's a negative on the inside, it will flip it over the y. So we are going to go through a bunch of these.
Where's Jake?
He didn't like you.
Justin. Where's Jake? My buddy. My helper.
Guys, please stop.
He's on the cruise with them.
Please stop. Come on. Guys, you need to stop your side conversations, please. All right. So let's get started with some examples here. So we are going to graph f of x, f equals x squared, which is our parent, and g of x equals f of x plus 4. Before we do this, what do you know will happen with your function if you're adding 4 at the end? Yes. It will go up 4, yes. So it translates. So this is going to take our original graph and translate up 4. So we'll look at that. So the parent graph. What is the vertex of our parent graph?
0,
0, 0, because we have nothing between here and nothing added at the end. So that's our HK value. Okay, ready? Out 1, Blaine, up. If we go out 1, we go up. 1 squared is? 1. So if we go out 1, we go up 1. Jayla, if I go out 2, I go up. 2 squared is 4, so yes. Justin Powers, if I go out 3, I go up. 3 squared is 9. So we create this parabola for our parent. So this is f of x. So yes, this translation says we need to translate our graph up 4. So we are going to take all of our points that we just plotted, and the ones we can, we're going to translate them up 4.
Okay.
Because this tells us, listen to why. This tells us that the new graph, g of x, takes the graph of f of x, which is x squared, and moves it up 4. Do you guys see how to read this? So our new graph, g of x, takes our old graph, f of x, which is x squared, and translates it up 4. So that's why that is happening that way. So who thinks they know the equation for g of x? Who thinks they can tell me the equation for g of x? Mike?
X cubed.
Cubed.
I mean,
X squared.
oh, that's not what I was. Parentheses. Plus. 4. I gotta get that 2 in here somewhere.
Where does, okay, stop for a second here. Where is our vertex? Okay, so vertex is at 0, 4. What is the value then that goes in for h? What is our value that goes in for h? 0. Our first one is 0. So really we have x plus 0 squared plus 4, right? So g of x equals x squared plus 4. That's our new graph. Think about that. This has a vertex at 0, 4, right? And it tells us to go out 1, out 2, up 4. Is that what we just did? So stop for a second and look at this real quick. Why did I put a square on the inside there? Sorry, guys.
Alright, so
Is it the top or bottom? What do you... This here is g of x, so it's this one. Because g of x is named here. Because it shifts it up 4. So look at this another way, guys. Please focus for a second here. Look at this another way. F of x is the same thing as x squared. So if it's the same thing as x squared, can't we replace f of x with x squared? Isn't that what we got? X squared plus 4?
Yes.
Okay, so explain how the graph has been transformed in terms of the parents. Well, we already did that, so I'm going to just circle this. It translates our graph. I don't know why you guys are throwing stuff. It translates our graph up 4. Okay, look at the first example and see what questions you have for me. Yes.
I have 2 questions.
Perfect.
Okay, the first one is, so whenever it's like the first equation, like the parent, it's always just like the kind of like default numbers, or it starts at 1 and then it goes up.
Kind of like when you're doing a line, if you start at 0, you would just go up 1 over 1 and it just creates that. Yeah, it's like the parent is a good way to say that is the default. Like if you were to default your settings on anything, that's what it would go back to. Okay? What's your other question?
Do you have to write the equation?
No, it doesn't ask you to, but I want you guys to get used to seeing the equation just because some of the time you'll have to ask it, and there might be a question similar to something like that on your test.
So on the homework, do we need to write the equation?
If it says to write the equation, yes. It depends on what the question will say, because I think some of them are a little bit different than others. All right, so what is going to happen here with f of x minus 3? Well, first of all, let's graph our parent. Our parent, as Connor just said, is a good way of saying it, is kind of like our default. This is where we kind of default back to if we have no clue where we're going or need to change things. So we start with a vertex at 0, 0. So, Jack, if I go out 1, I go up 1. Brian, if I go out 2, I go up. Be careful. 2 squared is? 2 times 2 is? 4. Okay. If I go out 3, Jordan Coward, I go up 9. 3 squared is 9. Okay, so we create our parabola. What is this one telling us we need to do?
Translate down through.
Be careful, it's inside the parentheses. So this is like the x minus h squared plus k. Yeah, so h goes side to side, left and right, right? So we know because it's negative inside of our formula, right? Since it is negative inside of our formula, we do the opposite. So instead of this going left, it goes right. So this is saying we are going to translate all of our points right 3. So I'm going to take all of my points and translate them right 3. So you guys should all be translating your points right 3. And don't forget to label your graphs because we definitely have 2 different graphs on here. So the first one is f of x and the second one is g of x. So label them so you know which graph is which. Yes. And get really used to that for that second day of the EOC where you guys are going to have to do like graphing and stuff to make sure you're labeling stuff for the EOC. All right. That is coming up here. You guys have like a month until your end of course exam. All right. So the next thing here is we need to talk about what this equation would look like. Where is my vertex on my g of x function? Where is my vertex? Comma. So if we were to take this and plug it into x minus h squared plus k, we know that h is 3 and k is 0. So what do you notice just happened for our function? What did we just do with this? This just went in here, right? Do you guys see that? That makes sense because this says this is x minus 3 is our input. So wherever we see an x, we need to input that into our x. Well, if we input that in here, isn't that just x minus 3 squared? That makes sense. Another thing I want to talk about is this pattern that we were referring to yesterday over and over again. Do you notice no matter where this is at, it's up 1 over 1, up 2 over 4, up 3 up over 9. That's because all h and k are our transformations. It's taking that default, that parent, and moving it 3 spaces. Does that change your size if you're moving things 3 spaces?
Go directly to
No.
jail.
So that is why that is happening. And then we already discussed its transformation in terms of the parent function. So that will go here. When you're ready, go ahead and flip. If you have any questions for me, let me know. Next Wednesday or Thursday. It's a 3-question quick quiz on graphing vertex in vertex form before we start talking about standard form. Yes, you do. Because you have all 8 days next week because you guys have Friday off. All right.
Miss Fry, can you go back? I haven't down yet.
Come on, guys.
Speak up.
I have a lot written down and you're not paying attention. Come on. Start looking at the next one if you're not there and start thinking about what you think f of x plus 4 will do inside the parentheses.
He's good now.
Okay. Okay, so again, our default is always known as the parent. And we take our parent and we graph it. It has a vertex at 0, 0. RC, if I go out 1, I go up. Blaine. If I go out 2, I go up. If I go out 2, I go up. Guys, I said Blaine. Josh, if I go out 3, I go up. 9. And you should be doing this at the same time I am, guys. Make sure you're paying attention. So this is the graph of f of x. So we need to think about what our transformation is saying. It says the new graph, g of x, is taking out f of x, and inside we are inputting for x, x plus 4. What does that make our graph do, Kaylee? So it's inside, and we know that our inside x minus h makes it go opposite, and it goes left to right. So this one is going to go left 4. Yep. So I'm going to take all of my points and translate them left 4. What'd you say? We share a point on this one. One of them lines up. We're not doing like solving a system. We're just, graphing them and showing the translation. Okay, guys. So this is going to take our graph and translate it left 4. So what happens to our vertex? It goes negative 4, 0. Does your vertex kind of tell you what your translation is doing? Yeah, it does. This means the x value, so this means left 4, stay put with our y. It doesn't move up or down. Do you see how that vertex can be kind of helpful when it comes to the transformations? Again, do you see how the size is preserved when we just shift it up or down? Or left to right? Who thinks they know the equation for this one? Who thinks they can tell me the equation? Blaine?
G of x, parentheses, x plus 4, parentheses.
Something is a little off here. No, it's not. I was joking. You're good.
So funny.
Just kidding. All right. So, do you guys have questions on that one? Yeah.
Where'd you get that squared from on the equation?
Because we are substituting in negative 4 in our original equation. So x minus negative 4 becomes a positive 4, and it's squared here. We have no k value at 0, so that's why nothing's there. Does that make sense?
It looks like V carrot times 2.
All right.
I did so good in cold.
Okay, time to focus. Okay, so we are going to state the transformation. What is my transformation on this one here? What do you guys think the transformation is going to be?
Down.
Yeah.
Sorry, Greg.
It translates down 5. Good. So what is my vertex of f of x? What is the vertex of f of x?
It's always
0, 0. What is the vertex going to be of g of x?
0, negative 5.
0, negative 5. Because it's translating the vertex down 5. So we start at 0, 0, and we go out 1, up 1. Mike, out 2, up
1. No, 4.
4. Jayla, out 3, up. And this is the graph of f of x. Okay. Now we need to translate all of our points down 5. So I'm going to take all of my points and take them down 5.
That's amazing. You're like a mathematician.
Guys, be nice to each other.
Yeah, Connor.
Sorry, Riley. Please cut me.
No, Connor, seriously, stop.
He said please.
I don't care. It's rude.
I'm sorry for being rude.
Apology not accepted.
All right. Connor Clover, what would the equation of g of x be then? I don't know why that just happened. I'm sorry. What is g of x equal?
G of x equals,
So think about the original equation as y equals x minus h squared plus k. So what is my h value? 0. So we'll plug in 0 there. So that's x minus 0 to the...
Does the x always stay there?
We'll talk about it. What?
Wait, squared.
Squared. And then plus or minus. What are we going to do? Minus 5. Good, because that's your k value. So this is really g of x equals x squared minus 5.
Noli. The x always stay there?
The x?
Yeah, well, that
Yes. It's like in y equals mx plus b. Remember, y is the same thing as f of x, so g of x.
Nothing will substitute in for that.
Unless you're like trying to prove that it's a point on the line, maybe, or something like that. But like in y equals mx plus b, we only usually substitute in for m and b. The reason we do that is because m and b are constants that have exact numbers, but y and x are variable, like variables that can vary based on like what your x is, your y would be different. So that's why we have to do it that way. And what is the vertex of that one there? Are you answering my question, Mike, or do you have a question? Just 1 second then. Colin, what's the vertex of that graph?
Alright, the vertex is going to be 0 and then -5.
Good. Mike, what's your question?
For the equation of g of x, do we put the first one, or do we have to decide?
First one. This isn't an equation. This is a transformation. This is the one that you're supposed to write it as. You're supposed to simplify it. All right, so what is going to happen in our next one? What will happen? Tanari, what do you think is going to happen in that next one?
Right 1, down 2.
Careful.
Down 2, right 1.
Left
That's the same
1,
thing.
Down 2.
So this is H. This is K. So H is opposite. So we go translate. Left 1. Stop throwing things. Down 2. Yeah, that's the same thing. So if we translate left 1 down 2, or the other way that you guys have been saying it, will that change the shape of our graph? No. It will just move it over. That's why it preserves that pattern. So g of x has a or f of x has a vertex at what?
0, 0.
And where would g of x's vertex be based on the fact that we're going left 1 down 2? Left means it's going to be?
-1.
And down means it's also going to be?
Negative 2.
Do you see how that transformation basically tells you what your vertex is? So you can get that transformation from your vertex. So we plot our points. And if I go out 1, Kaylee, I go up.
1.
And if I go out 2, Gianna, I go up. And if I go out 3, Justin Crater, I go up. So we are going to have to take every single one of our points and go left 1, down 2. So left 1, down 2 for all of our points. I should have connected our original points first so I don't get confused. What looks like an 11?
No, she's talking about mine.
Oh, I thought you were talking about mine. So again, you go left 1, down 2 for all of your points. So you'll notice, is it the same width as our parent graph?
Yep.
Yes, it is the same width. It preserves the shape. It preserves the shape, but it does. But it just moves it over. So what is my equation then? What is my equation going to be, Mike?
G, no, G, X, all, then parenthesis X,
Bless you.
It's okay.
and then -1,
Not minus 1.
I mean minus 2.
No.
What?
It's minus a negative 1. So that becomes,
Oh yeah, I forgot.
yeah.
And then minus 2 after.
Yeah, minus 2. So minus a negative becomes a,
Positive.
that's why it's the opposite sign. Remember when we put it in or take it out from the vertex, we get the opposite sign. So we already have stated our vertex as negative 1, negative 2. Questions there?
No.
Okay, let's skip the next slide.
Let's skip it.
Yeah.
And we're going to go all the way to the last slide now.
Hold up. Okay. We just found the
One second. I know. Go back to the very front page where we talked about our transformations and tell me what f of negative x said to do. It does. So this is a reflection over the y-axis. So here's the thing. This means wherever we see an x in f of x, we are going to replace it with negative x. Well, think about this. This is to get to g of x. So g of x would equal negative x to the, what's anything negative squared?
Positive.
What do you notice that g of x is?
The same thing as the parent.
Why does that make sense that a reflection over the y would keep it the same as the parent? Because they're symmetrical, right? And if you're if you are at 0, 0, your line of symmetry is the y-axis, right? It is x equals 0, which is the y-axis.
Oh.
So if you were to fold it on top of the y-axis, wouldn't your two sides meet anyways?
Yeah.
So it has flipped technically, but it still looks the same because it is symmetrical. So we get the same thing here for both of them. But we can think about it this way. I'll try to use 2 different colors and see if it works out for me or not. So this side of it is going to be green. And this side will be blue. And that is still f of x. But when we do g of x, it would mean that it flips the blue side here. And the green side here. So do you see how it still is the same graph? But it just flips your two sides of the parabola. So you don't have to draw it twice. You guys can draw it once, but I'm just showing you guys with colors like what it would look like if you were to look at it with dual colors.
You have a green slide.
So we already said g of x is equal to x squared, and our vertex is 0, 0, which means our transformation is just that it reflects over the y-axis based on that fact.